Hello, good day to all my Form 5 students. Today we are here to continue on our chapter Thermochemistry Part 3. In this chapter, I am going to discuss and highlight on the second type of heat of reaction, which is heat of precipitation. Now, if students can remember correctly, try to explain the meaning of precipitate. So precipitate is the product when the precipitation reaction happens. Now, if students can remember chapter 7 on salts, form 4, okay, on salts, students can find the meaning of precipitation where a reaction which produces insoluble salt. Precipitation is a reaction where two soluble salts react to produce one insoluble salt. And this reaction is called double decomposition reaction. So this reaction is called double decomposition reaction. Now, we are not here to discuss on double decomposition reaction. But in this chapter, thermochemistry, we are going to discuss on what is heat of precipitation. So, the terms and concepts that separates the precipitation with heat of precipitation are this word heat change. Okay, so whether it is going to be exothermic, endothermic, whether heat is going to be released or heat is going to be absorbed from the surrounding, and the term 1 mole of precipitate. So these are the two key words which will differ when we are explaining about heat of precipitation. Now, heat of precipitation is heat change when 1 mole of precipitate is produced from its ion of aqueous solution. So we can even add here from its ion in aqueous solution. Okay, so that is the reason why students must know what is precipitate in first place. Now, allow me to give one example on precipitation method where a soluble argentum nitrate is mixed with soluble sodium chloride to produce soluble sodium nitrate and one insoluble argentum chloride. Now, silver chloride or argentum chloride is explained, or the term as here shows that it is solid and it is insoluble. So, this is double decomposition reaction where two soluble salts are combined to produce one insoluble salt. Now, I want students to understand on how to write the ionic equation. Now, this is chemical equation. This will be ionic equation. So, ionic equation, argentum ion mixed with chloride ion to produce argentum chloride. So, why we eliminate nitrate ion and sodium ion from the reaction? Because these two ions are not responsible to produce precipitate. So, in ionic equation, we take the most important product that we are highlighting. Here, we are highlighting on precipitate. Now, let's go to example on calculation of how to calculate heat of precipitate using the same argentum nitrate and sodium chloride example. Now, let's look at the questions together. Okay, calculate the heat of precipitation. So, highlight heat of precipitation. Now we have to highlight all the given information because it's very important. Now 25 cm cube 0.1 mole per dm cube of argentum nitrate and 25 cm cube 0.2 mole of sodium chloride. So I am basically using this example, okay, to solve this problem. Okay, now, but I hope students can understand that 0.1 mole versus 0.2 mole, 0.1 mole versus 0.2 mole. Can you see that the concentration of the solution is different? Okay, concentration of these two solutions is different. So please keep an eye on that. Second is, let's look at this term. Why have we added white precipitate is produced? So when white precipitate is produced, this shows the reaction has happened. So this is the reason why we add the word that white precipitate produced. That means indeed we have produced argentum chloride here. Alright. Okay, now, so information is given. Initial temperature of sodium chloride 28 degrees Celsius. Initial temperature of argentum nitrate 30 degrees Celsius. And the highest temperature of mixture. This means you have to mix sodium chloride and argentum nitrate. So the highest temperature recorded for this mixture is 35 degrees Celsius. Now, students, teacher have few things to explain here. First thing students have to take note is the concentration is different even though the volume is same for both the substances, mean both the salts. White precipitate produced, this shows that the reaction has happened. And please look at the initial temperature of both the salts are different initially. So what students have to do here is you have to find the average temperature, that is average initial temperature for both the reactants. So 28, 30. So 28 plus 30, you divide with 2. So we get 29 degrees Celsius. So please remember that the initial temperature of 29 degrees Celsius will be taken into consideration. So that's the first point students need to remember. Now let's go to second point. Highest temperature of mixture is 35 degrees Celsius. Thus, the theta, that means the difference in temperature is 35 minus 29, 6 degrees Celsius. Keep all this information in account. Right? Okay, now let's go to, now teacher have written all the steps for students to find the heat of precipitation for this reaction. Now, let's start. So can you see that I have written two steps here, which is first find the mole of argentum ion. Second, find the mole of chloride ion. Why am I interested in argentum and chloride ion? Because these make up the ionic equation. Indeed, argentum and chloride ion are the ones responsible to produce the precipitate. Okay, now, so let's look at this. So find the mole of argentum ion, MV over 1000. So all these students need to know because you are exposed to this calculation of mole in chapter 7. Okay, so now 25 times 0.1 divided 1000. So we have 0. So students can do it, teacher, 0.0025 mole. Okay, 0.0025 mole. Now let's calculate for chloride ion. Chloride ion Mv over 1000. So 25 times 0.2 divided with 1000. Okay, so you get 0.005 mole. Now, teacher would like to highlight one thing here. Can you see that you get both the ions different mole because the molarity or the concentration is different. So here I want students to go back to this idea. White precipitate is produced, meaning even though argentum only has 0.025 mole, ion only has 0.025 mole, this shows that the reaction has happened. So I want students to take this value as consideration for the calculation of heat of precipitation. Which I repeat, argentum ion, chloride ion that did not bring same amount of mole. In fact, chloride ion is more. But this word, white precipitate is produced and the temperature, can you see the temperature has indeed increased. So these are the two indications that the reaction has happened. So when this reaction has happened, this means that we always take the lowest amount of mole under the with the understanding that even though argentum ion has the smallest amount of mole, the reaction still happened. Okay, it's like this. I am selling a book for 10 ringgit. Students, I'm selling the price of the book is 10 ringgit. Student A brought 12 ringgit. Student B bought 10 ringgit. But the best part is both my students will be able to buy the book because one brought 12 ringgit, excess 2 ringgit. Another one brought exactly 10 ringgit. The price of the book is 10 ringgit. So can you see that even though one brought the minimum amount, one brought extra amount, still both of them managed to buy the book. So that is the concept that we are using here. Right? Okay, now, so second step, find the heat of reaction. So I hope students know that when calculating heat of displacement, teacher was only calculating the volume of the liquid involved, not the metal that is displacing the ion. Okay, I hope you can go back to part 2 of the thermochemistry lesson. Now, but here I want students to know that we are mixing two liquids. So since we are mixing two liquids, the mass, okay, so I've taught all of you on how to convert the volume into mass. So I'm not going to teach you again. Okay, so the total mass for M will be 25 plus 25. Why? Because in this reaction, both the reactants are liquid. So the combined volume must be taken into consideration. Okay, and times C. Okay, so we have known what is C. 4.2 times, okay, the temperature, the theta, the mixture of the temperature of the solution is 6 degrees Celsius. So let's find out what will be the heat of reaction. Okay, so 1260 joule. So the heat of reaction for this particular reaction, okay, for this particular precipitation reaction is 1260 joule. But now let's go to fourth step. Find the heat of precipitation. Now, in order to find the heat of precipitation, I want students to go back to the general term for heat of precipitation, which is heat change when 1 mole of precipitate is produced. Now, students, I told you that in this reaction, we are going to take mole of argentum as the consideration. We're going to consider mole of argentum. So, unfortunately, this reaction has only used 0.025 mole, but I am not interested in 0.025 mole which has managed to produce 1260 joule. According to the term of heat of precipitate, I want 1 mole. So we can do like this, which is 0.0025 mole has managed to produce 1260 joule. But according to the term of heat of precipitate, I want 1 mole. So how much of heat can be produced? So we are going to divide 1260 with 0.025. 1260 divide 0.0025. Okay, so we get 50400 joule or 0.4 kilojoule. Okay, kilojoule. So teacher prefer to change it into kilojoule so that you will be dealing with smaller number. Okay, so I hope until now students can understand. So please watch teacher's lesson video few times in order to grab the concepts. Alright? Okay, now for fifth comes the energy level diagram. So I have taught how to draw energy level diagram. Okay, so first thing, students, you have to decide whether you are dealing with endothermic or exothermic reaction. So the clue is in here. Highest temperature of mixture 35 degrees Celsius. This shows that the temperature has increased. So which reaction releases heat to the surrounding? Definitely exothermic. So once you decide it is an exothermic reaction, you must know on how to draw the energy level. So you must already know how to determine the energy level diagram of this reaction. So can you see the shape of the graph? Exothermic. Why? This one. Highest temperature of mixture has increased, did not decrease. Alright. So here teacher will prefer to write it's okay, you can write chemical equation or you can even write ionic equation, doesn't matter. So here teacher will write ionic equation. Same, you can write both, no worries. Okay, ionic equation, and the change in temperature is what you have found here. Okay, so now H negative 50.4 kilojoule per mole. Oh yeah, teacher forgot one thing. So once students get this, I want you to write this: heat of precipitation equals to negative 50.4 kilojoule per mole. Students, this is important. Once you get the answer for 1 mole, convert the information into this type of information. Heat of precipitation. Now why negative sign? Because again we know this is a exothermic reaction, so negative sign will come into the picture. And kilojoule per mole, so that is how you write for heat of precipitation. Heat of reaction we only use joule, heat, but heat of the reaction we use kilojoule per mole. Why? Because we want per mole, 1 mole. Okay, like per hour, kilometer per hour. So 1 meter, sorry, kilometer for 1 hour. It's like that. Alright, so that's the reason why we use per mole. Now, construct thermochemical equation. So thermochemical equation can be ionic equation or chemical equation, doesn't matter. That means you can use one of these, doesn't matter. You can use any of these. Alright. So maybe teacher thinks I already used here. I use this equation. Argentum nitrate add with sodium chloride to produce. Okay, so we can add aqueous here. Sorry, teacher forgot aqueous. To produce sodium nitrate aqueous plus argentum chloride solid, and the heat. So thermochemical negative 50.4 kilojoule per mole. Okay, so negative 54 kilojoule per mole. So can you see that we can use the information heat of precipitation that we managed to calculate to construct energy level diagram, to construct the shape of the diagram, and also to construct the thermochemical equation. So students, I hope students can understand what teacher have explained regarding heat of precipitation. In part 4 of our thermochemistry lesson video, teacher will explain about heat of neutralization. Okay, so I hope students can understand what have I explained here, and please watch my lesson video few times in order to understand the concepts. Okay, so till then, see all of you. Let's see all of you in next video. Till then, take care and thank you for watching.